So today we're gonna go back. We're getting ready for the ACAP testing that's coming up. We're gonna go back and review some of the things that we've covered already, but just to make sure that we're prepared. So we're gonna back up and look at matter. So what is matter? What is matter? Atoms. Okay, atoms make up matter.
Anything that takes up space.
Very good. Anything that takes up space. Okay, so what do we say if something takes up space? What is that? How do we measure that? How do we measure the space that something occupies?
Matter.
Volume. Very good. Volume. So anything that takes up space has volume. And then you said, what was it, Carson? Mass. What is mass?
Weight, right?
Yeah, right. So anything that has mass and volume, anything that has mass and takes up space is matter. Now, what things in the classroom right now are matter? Well, what is matter?
It takes up space.
Everything, okay?
Like the clock, the pictures, the tables.
Us, right? Okay, who says oxygen? Oxygen? Absolutely.
Like for
Oxygen is matter.
I don't know.
Yeah, oxygen is matter. So think about this. You really can't see it, but when y'all were in the auditorium earlier, when we come through the door, what was around the door?
Balloon.
Balloons. Why were those balloons like they were?
It's the air.
Because there was air in there taking up space. Therefore, the balloon was inflated, right? So even air is matter. Now, the mass of it is much less, and it takes a little more of it. So we're going to talk about, now, when you talk about a solid, so we've got solids. First thing I talked about was solids, like the tables, the walls, the clock on the wall. What's the difference in the molecules in that versus the molecules in the air?
The molecules in the air are moving.
Molecules in the air are moving faster. They're spread out, right? So they move around freely. What about the molecules that make up solids, like the table or the floor? Very tightly. Do they move? Yeah, all of them move. They move very little, right? So we have air, which is spread out and moving around. We have solids, which are packed tightly. What about this? What's the difference in these molecules?
They're, they have no state of mass.
Do they touch one another?
Yeah.
They're moving, but they're still touching.
They're moving freely, but they're still touching. Versus that of a solid where they're very rigid, the liquid moves. Which one will you get hypothermia in faster? Air or water?
Water.
Water, why?
Because it has more freely moving.
More molecules, right? So in air, you have space and you have air, but in water, more molecules are touching. Your molecules make up, so therefore you lose more heat in water than you do air. So, very good. All right, so let's talk about matter. We're going to talk about different properties that distinguish matter. We've kind of gone over some of that and reviewed some of that. Matter's all around us. We know. We've looked at it. We've identified some things around us. Properties of matter. All right, matter. Basic definitions y'all have already got. It's anything that takes up space and has mass. So if it has volume and mass, then it is matter. It's also made up of atoms and molecules, and this definition makes it seem like matter could be anything around you, and that's mostly true. For example, computer, matter. Breakfast you ate this morning was matter. Even you are composed of matter. All those things are made of matter. Then what type of things are not made of matter? Huh? What's not made of matter?
Nothing. Ideas. Thoughts.
That's true. That is true. Boom. What about, y'all remember back to energy? Okay, does electricity matter? Is light matter?
No.
Okay, so let me ask this question. What about sound? So we're going to go way back. So we talk about sound, light, electricity.
No.
Does sound require matter?
Yes, sound does.
so sound is a transfer of a wave through matter, right? Well, does light require matter?
Yes. No.
It's not
I
matter.
mean,
Does light require matter to transmit?
no.
No. Alright, because if it did, we'd freeze to death, right?
Yes, sir.
Would be warm outside because the light from the sun wouldn't make it to us. But because light can travel through that which is not matter, so what is not matter? In space, you have the absence of matter, right? Now, it's not that there's no matter, but it's so spread out that there's not enough around, right? So there's little bitty stuff out there, but not enough of it. So we get the light from the sun to the earth, and it can travel through that which is not matter. So anything, basically, that does not take up space or does not have mass, by definition, is not made of matter. Light, sound, they're not composed of matter. Now, the difference between light and sound requires matter in order to transfer. That's why if you yelled in space, would anybody hear you? No. There's no matter for the transfer. The atom. We're going to talk about the basic building block of all matter. So all matter comes up, and you know, we looked at yesterday, who was the guy that said everything is made up of indivisible or undividable particles? Who was it? Who's the Greek guy?
All over.
Four hands.
Oh, it's the.
Democritus, right? Remember Democritus? And then Aristotle came back and said, no, that's not what it is. And then we come back with Mendeleev and then John Dalton. So John Dalton wrote the book based on Mendeleev, and then we advance from there, and we come to where we're at today. So, basic unit of matter is an atom. Atom's the smallest unit of matter that can be divided. Matter is the smallest unit of matter. Can be divided into, while still retaining its chemical identity. So once you get to one atom, it still remains its identity, but if you were to divide that, it loses identity, correct? Atoms are often considered to be the building blocks of matter. Matter can exist as a single element, which is a substance made up of identical atoms, such as hydrogen and oxygen. It can exist as a molecule, or two or more atoms chemically bonded that act as a single unit. Matter can also exist as a compound, okay? So we've got an element which is a single atom of one pure substance. It can also exist as a molecule, two or more atoms chemically bonded that act as a single unit. All right, somebody give me an example of a molecule versus an element.
So a molecule is like.
Okay, H2O, that's a high quality H2O. H2O is a molecule, right? Because what's the chemical formula for H2O?
Hydrogen and
H2O, right? H2O, H2O. Two hydrogens, one oxygen. All right, so that is a water molecule. So once you divide that to an H2O, yes, there are three elements, but it is a molecule. You can't take it any further. If you're to split water, what do you get? If you're to divide water, hydrogen and oxygen. And how could you do that? We're actually going to do that, right?
We're gonna make water.
Is it gonna make a boom?
Later on this week, we're going to do it. So what we're going to do is we're going to take the water, later on this week, we'll take the water and we'll actually pass an electric current. Now, we've got to add something to the water, correct?
That's right.
Minerals.
We could add sodium chloride, sodium bicarbonate, anything that would, right on the periodic table over there on the left-hand side, any kind of metal, because one of the characteristics of metals is what?
Conductive.
It's conductive, right? Water by itself, no, but when you add those to it, then you can make it conductive. Once we pass that current through there, we're going to take and divide. What do you think you're going to see when we pass current through there?
Sparks.
What's-
It says
Bubbles.
second,
Bubbles. We're going to see bubbles. That's going to tell us that what's happening.
A chemical change.
chemical reaction, which is a chemical change. And we're gonna take water molecules, divide them, and we're gonna have hydrogen and oxygen. Which one do you think is gonna fill up faster?
Hydrogen.
Wait, yeah.
There's two oxygen, or no,
one
H2O. Okay, two hydrogens.
Two hydrogens?
More hydrogen.
And one oxygen. So which two do you think is gonna fill up faster, the oxygen or the hydrogen?
The hydrogen.
Okay, we're gonna remember that when we start doing it, then we're gonna talk about it then. Okay?
Definitely wrong.
All right, well, Juan says oxygen because she says it has a greater mass.
Oh, bubble.
Oh,
So
yeah.
what we'll do is we'll find out. We're gonna find out which one
I'm sticking with hydrogen.
which one we're gonna go with. Okay, so we got some hydrogen takers, we got some oxygen takers, and we'll find out later on in the week, which is it's gonna be a fun experiment. But
Even
anyway.
though it's gonna be
All right. So molecules.